Hello, Flat Earth researchers, debaters and debunkers. Here I have an ad hoc setup similar to what globe defender Sly Sparkane is going to use in order to pull off a deception in which he will appear to prove that we live on a globe, because he is going to apparently measure bendy water. So I'm going to show you how this is going to be achieved if he can get clear results on the day. What he's going to do is set up tubes that will be filled with water. So let's first have a look at some screenshots from Sly's own videos in which he illustrates how he's going to create the experiment and how he's going to perform it. And this will also at the same time illustrate how he's going to carry out the deception and lead us to believe that he is measuring a bulge in curvature or bending water. So first of all, what he has proposed is a setup here of vertical pipes that are all connected, and they will be filled with water of a total length of 1,600 meters, because there is going to be 100 meters between each of these vertical pipes. And then 100 meters away from the first pipe, which he's going to call pipe 0, will be the camera. Now it's from the camera that he's going to continue the setup and how he's actually going to set up the illusion of bendy water. So we know that if we fill all of these connected tubes and vertical pipes with water, we will get a water level that's consistent across the top here. This will be our water level. And as he rightly points out in his video, it doesn't matter if the terrain or the ground that it's lying on is completely flat, or if it's sloping one way or the other, or it's raised or bumpy. We ultimately get a water level that's consistent across the top. Now, of course, his plan, and he's quite confident that he's going to be able to demonstrate bendy water, a bulge of curvature. And this is because he understands how to change from this, or give us this orthographic side-on view, but everything is going to be done from the point of view of the camera, with the tubes, the vertical tubes, going off into the distance in line with the camera. Okay, so by changing the perspective and the point of view while giving us this illustration is how he's going to create the illusion of bendy water. Now, one of the things he mentions in one of his videos is that he's not going to be looking at a tangent. Okay, so this is what we would normally do or assume if we are on a sphere and we look directly ahead with a horizontal line of sight. It doesn't matter where you are on the sphere, but water or the surface would be curving down and away from you. So he mentions early on that this is not what he aims to achieve. What he aims to do is illustrate a chord. So in effect, he's going to show a bulge of water, okay, by doing it this way. And this is quite instrumental in the way he's going to set it up in order to create the deception. So this is what he is going to attempt to demonstrate, a bulge of alleged curvature. And if he does get clear readings from the camera, remember, everything is going to be done from the camera, he will in fact appear to create a bulge, because there will be a difference in or an apparent difference in the levels of water. Now, the way he's going to do this is he's not going to use the ground or the surface as a baseline. And what would appear to be a sensible decision is to create a new baseline by attaching a light to the last vertical pole, the one that's furthest from the camera. So this will be almost 1 mile away from the camera. He's going to put a light on this last pole here, which he will refer to as the marker. And from there, he's going to, one by one, all done from the point of view of the camera, put clips. Now, the way he's explained it is he's going to have the marker or the light on the last pole here, or tube. It can be an arbitrary position, but it will be somewhere below the water line. So the tubes will already be filled up with water. And if at that point we actually, I don't know, put a laser or something, or found a way of showing a line of sight across the top of this water, we would find that it is in fact level, regardless of the shape of the terrain. But that's not what he's going to do. He's going to create a baseline. So a light here on the last tube, and then on the next tube, which again is going to be 100 meters away from this first tube, all done from the view of the camera, he's going to take a clip and move it up and down until that clip eclipses the light shining from here in the view of the camera. Okay, so he'll put a clip here, and then once the clip is obscuring the light, it's blocked off the light, he will take a marker pen and mark the tube, the vertical tube there, to create his first baseline, and then take away the clip. And so it will go on. We'll go on to the next vertical tube. So using the marker here, okay, he will then again put a clip on here and position it until in the view of the camera it is obscuring the light here. All right, okay, and then and so it goes on. So what we will assume will happen because of this is something like this. These are the marks created after putting a clip on the tube that is blocking off the light on the tube beyond it. Okay, and of course it will be assumed that all these markings would naturally be in line like this. But that's not what is going to happen. What's actually going to happen is that because everything is going to be aligned and set up through the eye of the camera over here, rather than using this side-on view, the whole thing is going to be affected by perspective and changes in angular size. So over here we have the marker or the light that Sly is going to place somewhere below the waterline on the last pole, the pole furthest away from the camera, which is going to be about 1 mile away. Keeping in mind that each of these poles is going to be 100 meters apart, which is one reason why we won't see 2 or 3 poles together in this side-on view like this. But this is an excellent excuse to do everything through the eye of the camera. So it will be affected by angular size. Of course, this is the horizontal baseline that we would assume would occur, or that we would get if everything was being measured and aligned through this side-on view. But in fact, it's all going to be affected by the change in angular size that we can see represented by these pink lines here. Now, Sly knows about this, and he knows how to change a perpendicular or side-on orthographic view into a view of perspective by taking angular size into consideration. So these pink lines just represent how much larger in angular size something close to the camera will appear compared to the poles that get further and further away, and therefore we get a reduced angle, okay, smaller and smaller in angular size as they go off into the distance. So these pink lines in this side-on view represent the change in angular size that we would see through the eye of the camera. Okay, so what we'd end up getting is not a baseline that's horizontal, but you'll see these yellow marks is what we would get on each of the poles, getting lower and lower as the poles get closer and closer to the camera, because they are following this line of angular size down here. He's not going to worry about the top line here, he's just going to use this bottom line. So he's setting up the baseline to be in line with the change in angular size that we will see through the eyes of the camera, rather than the horizontal line that we should get from an orthographic or side-on view. Yeah? Okay, that's what we're going to get. The reason we're going to get this is because the closer and closer these poles get to the camera, the less you'll have to move the clips up in order to block the light over here. The light's going to remain here, and each time you place a clip on one of the poles that's closer and closer to the camera, you'll have to raise the clip less and less each time. So this is actually going to make the baseline get lower and lower and lower as the clips are placed for the baseline markings closer and closer to the camera. So what he's going to do after that is, once he has placed the marks on the poles, which will be there, of course we won't see this difference in the marks on the baseline marks on the poles, because he's going to look at them one by one. We're not going to see them lined up like this. If we saw them lined up like this, we would see how the baseline is staggered like this rather than being a straight line. But that's not going to be shown because the poles are so far apart. We just won't notice the few centimeters or inches in difference that will occur between each of the poles. Yeah, again, this is how the deception is going to be carried out. So the next thing that will be done is that he's going to get I think it's 15 centimeter divider, and put it on the baseline. So there will be clips here now. Once these have been marked off, he's going to place a clip on to mark the baseline, and then he's going to place clips on top. A second clip is going to go here 15 centimeters away from the bottom clip. So that will be like this. So in effect what ends up happening is that each time he's going to go along and place this divider on each of the poles before putting a clip on the top to make sure that there's 15 centimeters gap between the lower clip and the top clip. Okay, so of course you can see that each time he does so, you're going to get a difference in the gap between the water level and the top clip, and the baseline and the water level is going to be different for each pole. The gap between the top and the bottom clip will remain 15 centimeters, but we will see a difference in the gaps between the water level and the top clip, and the water level and the bottom clip. And you can see here how this will appear to create a curve. Basically the baseline will appear to rise up, and it will appear from the eyes of the camera again that we have bulging water coming up like this. Yeah, it won't be following that baseline, okay? Everything will be following these lines created by the change in angular size as seen through the camera. I'll just show you here what I mean. This is one of Sly's own illustrations. So each pole, once it's been marked off, he's going to go back again and put the clips back on each of the poles. At the bottom one where it's been marked off, then a 15 centimeter divider, and then another clip. And then after that, he's going to put a third clip here and mark off where the water level is. And then all of the poles are going to be viewed through the camera. So of course what will happen is that you end up with a view of clips that will appear to rise up. Yeah? Everything will appear to rise and create a bulge of apparent curvature, simply because it's all being done through the eyes of the camera and governed by perspective. So let's go and have a look at how this actually works with a scaled down version of the experiment. Okay, so this represents the marker that Sly is going to use, yeah? And he's going to place it on the last tube, most distant from the camera, and then he's going to use clips to eclipse the light and then draw a mark, okay, like this on the tube. But of course it's all going to be done from this perspective, okay? So we'll see how he's going to create this baseline. Got a pen here, okay, and what I'm going to do is use this bottle to represent the clips that he will place on the tubes. Alright, and I think I'll also use this to show where the markings are going to appear. Alright, so this is the way it's going to work. The camera, Sly's camera, is always going to remain where that camera is now. It's going to, okay, so of course for the most distant marker, what he's going to do is take a clip, alright, and he's going to raise the clip up until it blocks off the marker, blocks off the light attached to the last tube, okay? So I'm assuming that's somewhere like here, okay? This is going to be quite difficult to do with just myself. Alright, so I've just made a mark here on this one that's the same as this one. So, another 100 meters along, he's going to do the same. So the marker remains there, the light remains there, and he will have to then lift up the clip to block off or eclipse the light again. Okay, it's difficult to see exactly if that's blocking it off right now. Let me just try and zoom that in to see if I can. Okay, so we get it about there. Oops. Let's see. Boop. Okay, so that's the height at which, yeah. So in his video he explains that once the top of the clip blocks off the light, eclipses the light, his marker, is where he will then mark the tubes to create his baseline. Okay, so So let me just bring this bottle here now, and see here that this line is now somewhere around here. Okay, right, next bottle along, remembering that there's 100 meters between each of these bottles, so just zoom out a little bit more. Okay, so we're on the 1, 2, 3, we're on the third bottle now. Again, the water is level, the water's all the same level, which will naturally be. Sorry, we'll put this here now, which is our clip, and we raise up the clip until it blocks off, until it eclipses the light. So I think it's eclipsing the light now. That's about right. I've got a mark there. Okay, now on to this one. Oop, it's eclipsing the light. And it's there. Now on to this one. Now you can see I hardly have to raise this to eclipse the light. You see, it's very simple, yeah? It's just using the difference in angular size. Yeah, if I bring this closer to the camera, I don't even have to raise it now to eclipse the light. So that, yeah? So the further away we get from the camera, the greater the apparent distance. Yeah, so the more I would have to raise this to eclipse the light. The further away we get, the more we have to raise this to eclipse the light. So again, he's going to place clips one at a time on the tubes, starting over here at the final tube, raise it up as much as it needs to be raised to block off the light here, to eclipse the light in the view of the camera. Yeah? Okay, so he goes to the next bottle. Doesn't, because this is now closer, doesn't have to raise the clip so much. All right, so we've got two lines here. Let's put a third. Let's see where we marked this bottle. Okay, let's see where we marked this bottle. Oh, zoom out a bit. Okay, that's somewhere around here. Okay, and this final bottle is marked somewhere around here. Yeah, so I think you should see now what's going to happen is the baseline that he creates is going to be low here, and so we get a greater distance between the baseline and the water. And as we go back, this line, you can see, let's just line all the bottles up like that, just so you can see where I've marked them. Okay. Yeah. All right, you can see that on the last one, we had to raise what would have been the clip before we made the mark on the pole quite high to block off the light over here, which remained fixed. Okay, this had to raise up quite high. This one slightly lower, because this appeared larger and closer to eye level as we got closer to the camera. And then this one slightly lower, this one slightly lower, and this one slightly lower. Okay? All right, do you see? So while it would appear that he created a straight baseline by lining everything up with that light in the distance, 1600 meters away, each 100-meter increment between the poles would mean that the baseline actually gets lower and lower and lower and lower.
because the clips would appear to get closer and closer and closer to the camera's eye level and reduce the gap in apparent size so that you wouldn't have to lift it so much. Yeah? And so, of course, what happens is here we have a great distance between the water level and the mark. And here, less of a distance. Okay? But because these are going to be 100 meters apart each, we will not see that the water is actually level in the tops of the tubes. But what he's going to do is measure the distance between the mark, the baseline, and the top of the water. And of course, what will happen as he goes down the line, it will appear that we'll have bulging water. Yeah, you end up with a curve. And this is really, it's quite clever, but it's also quite simple, because it's what we've been saying all along. Perspective is the imaginary curve. Yeah? All right? Remember, it's all going to be done from this perspective, where we will see a decrease in angular size down the line. That's why he's doing it here, and that's why he sets up the marker over there, and that's why he's going to set up the baseline from there and bring it closer and closer to the camera without giving an orthographic or side-on or perpendicular view. Yeah, it's quite simple. Yeah, it's it just shows that Sly actually understands perspective, and he's using it to his advantage to create what will be the illusion of curvature, because it will appear that there is more water between, or sorry, less water between this baseline than this baseline, which will appear to have more water, even though the water will be level. Okay? And again, as I said, it doesn't matter what kind of terrain the apparatus is set up on, because that's his excuse for creating a baseline based on a light at the far end of the experiment. Yeah? I hope you understand. Yeah? It will be level. The water will be level, but he's going to create the illusion that it's not level, and he's going to create the illusion of a bulge of water. In fact, this is why at the beginning of his explanation of the experiment, he explains how he's not going to demonstrate a downward curve from the observer. He aims to demonstrate a bulge of curvature. And that's why. Because he knows that this is the effect he's going to achieve. All right?
Now, Sly Sparkane and other globe defenders who often rally against globe deniers and flat earth researchers will claim that we don't know science. But we have been pointing out for a long time that observations are not the same as measurable proof. In fact, I'll repeat again, the globe has been imagineered by translating perspective into an imaginary curve. The entire globe-Earth model is based on observations that have been converted into explanations and passed off as science. There has never ever been any physical measurement of any kind of curvature on the surface of the Earth. It's all been done by making observations that are governed by perspective and pretending that that is some kind of science. There is a huge difference between making an observation and measuring substance. Real physics, real science is the measure of substance, physical measurements. Making models and assumptions and interpretations from observations is pseudoscience, and that's why I keep saying perspective is the imaginary curve. Now, if Sly was going to be truly scientific, he would try to verify his findings. Again, he's going to make observations and then he's going to base measurements from observations and claim that he's made alignment from observations. Now, what he could do is simply get a laser and fire it across the level of the water, across this mile of water, just as a way of verifying that whether or not he's observing bendy water or flat water. But he point blank refuses to do this. Let's just hear it from himself.
I am not going to use a laser on this test ever at all. It will have absolutely no use. This is going to be for an observation, okay? The observation of the bend of water, the arc of water, over the course of 1,600 meters. Yes, William Sines, globe math.
Okay, so there you go. You heard it from the horse's mouth. He is not going to use a laser, and the entire premise of this test is to make an observation. Not to seek measurable proof, but to make an observation and pass that off as curvature. Okay, this next clip from the same hangout, we have globe believers and, I believe, flat earth researchers in the chat telling Sly that by making observations alone, he is not going to get a straight line. Now, part of the argument was refraction, but there are people in the chat pointing out that if you use only the camera to make an observation, you will not get a horizontal line. Now he's going to refute that. Let's just hear what he has to say.
Meaning that they are not optically aligned.
Yes,
They're
I
made
agree.
at the pipe. So what that will actually do is if my line appears to, if my optically straight line is actually bending upwards, okay? If my optically straight line is actually bending upwards, then what that will actually do for the test is actually pronounce more the curvature that's being shown by the water levels.
Okay, so it appears that he actually knows that by making this observation with an optical instrument, he's going to appear to get a straight line, but he knows he's not going to get a straight line. Now he's making excuses for refraction. This apparently a 17 degrees of refraction was mentioned. So he's now preempting that he will get this rise in the level of the baseline, as we've demonstrated just now with the bottles. I think he realizes that he will get that, but he's going to claim that it's refraction, or put it down to refraction, and he's also going to claim that this will somehow also prove that he's seeing a bulge in front of him, because we're going to get this rise. So it seems that he knows what's going to happen when he makes these observations. He's not going to get a horizontal line, but he's going to claim that's what he's observing. But then if it turns out not to be horizontal, then he's going to put it down to being a bulge.
Because the water levels are not optically aligned.
Well, obviously it would give a slope to the entire lower baseline.
Well, but it would be increased, and so therefore it would actually show a little bit more of the curved uh, water heights than anything else. So either way, like I said, if it turns out that the hump that is shown on this, okay, if we prove curvature and everything here works perfectly, okay, the hump will actually be greater than the 2 inches in the middle because the optical alignment will have actually bowed under it, as in bowed downwards under it, ultimately resulting in an upward physical curve, even though optically it'll look straight.
Okay, he's claiming that optically it will look straight, and of course, optically is the view from the camera. It's not going to be straight. Yeah? He knows, we know, that parallel lines appear to converge because of perspective.
So we will actually be creating a larger gap, so therefore even further proving, at least optically, what's going on. And because the second chord, which is actually just a parallel line to the measured chord or to the aligned chord, you will definitely see the difference in the water levels versus the two chords.
Okay, just to clarify there, he does know what's going to happen. When he talks about the chords, he's talking about the clips that he's going to use. So he's got the clips for the bass line, and then the clips for the top line, which are going to be 15 centimeters higher than the bass line on each of the vertical poles. And so he knows that the water level is going to appear to be different on each of the poles between the bass line and the top line, or the chords as he calls them. So he knows what he's doing. He knows he's setting it up to actually get the results we've seen with the bottles, and he's going to put it down to curvature. And so in this next clip, he's been challenged by someone in the chat that he won't get a straight horizontal alignment by making an observation with the camera. And we've just seen that that's, even if he gets the camera level, he's not going to get a horizontal alignment. So let's see what he has to say about that in this clip.
It's involved that I have posted, which I hope you have seen prior to making these comments. Okay? The clarity that can be achieved, if you are telling me that that is somehow impossible to line stuff up on using a P1000 or just a scope, okay? If you are telling me that I cannot create a straight line through that, I'm going to flat out disagree with you. And if you're saying clarity is irrelevant?
Okay, so there we go. He's claimed that he's going to get straight alignment by using the camera alone. So he's kind of contradicting himself there. He's also made remarks that could save him when he finds out that he doesn't get straight alignment. So this is what Sly does. He goes backwards and forwards, twists things around, and makes sure he's said things that he can go back on and save himself with, depending on the situation. But I suspect he does know what he's doing. He's not that stupid, but he's just going to, whatever the outcome, he's going to say that it somehow proves the curve, when we've already seen that what he's going to do is going to be the result of perspective and angular size based on observations, and then he's going to create measurements from those observations. This is exactly how the globe has been imagineered. So I look forward to the test because it will show what globe deniers have been saying all along, that the entire globe model is a fabrication based on observations, not measurable proof. And in order to support the globe, people have to be deceptive. And great, bring it on. You're going to prove that perspective is the imaginary curve. Sly, looking forward to it. Thank you very much.